Good morning, ma'am. Today I am going to present on an important concept in compiler design, dead code elimination. This topic is part of optimization techniques used by compilers to make programs faster, smaller, and more efficient. We use code every day, but not all code actually contributes to the final output. Some of it is simply useless, and that's exactly what we are going to explore today. Let's dive deeper. Here, I'll be covering in today's presentation. First is what dead code actually is, and then the different types of dead code, why it should be eliminated, and how compilers detect it. Some real life scenarios will also be covered in this today's topic. A before and after example, and then tools that implement it, and finally key takeaways. By the end, I'll clearly help in understand you how data code elimination improves program performances. Going to the next slide. Let's start with the basic question. What is dead code? Dead code refers to any part of the program that is never executed or executed but its result is never used. In simple words, it exists but in the code it exists in the code but has no purpose. For example, like think of it like expired items in warehouse. They occupy space, slow things down, but they never actually used also. A smart manager removes them just like a smart compiler removes dead code. Here we have an example. In this example, variable y is never used. The condition if false will never run. So both are dead code and can be removed without affecting the program output. There, there are several types of dead code, like unreachable code. This is code that will never run like for example, anything after a written statement or inside if else. And unused variables. Variables that are declared but never used everywhere in the program. For example, like writing notes in an exam but never using them. Unused functions. Functions that are defined but never called. It's like saving a contact but never calling them. Redundant fourth type is redundant computations. Calculations that are overwritten before being used. Example like solving a math problem and then erasing it before writing the answer. All these types are waste memory and processing power. Now the important question is why should we remove dead code? Faster execution. Faster execution. Less code means fewer instructions. So program runs faster, absolutely. And then smaller size. This is especially important for mobile apps and embedded systems. For better optimization. Other optimizations works better than the code when the code is clear and improved security. Unused code can contain hidden bugs or vulnerabilities. So it is important for improved security. Easier maintenance. Developers can understand and debug code and more easily. Lower energy consumption. Less CPU usage means less battery drain, right? Very important mobile devices. So removing deadline code is not just optimization, it's about performance, security, and efficiency. This is the most technical part, but I'll explain it in a simple way. Source code starts with code written in C, Java, etc. etc. Abstract syntax tree. This compiler converts code into a tree structure. Control flow graph. This shows how the program flows from one statement to another. If a part is not reachable, it is dead. Likewise, liveness analysis. This checks whether a variable will be used later. If it's not used, then it is dead. Constant propagation. Mark dead code. If the condition is always false, like if one is greater than two, then the compiler removes the blocks. Then using these techniques, the compiler safely removes unnecessary code without changing the program behavior. Dead code elimination is not just theoretical, it is used everywhere. For example, in mobile apps, removing unused code re- reduced app size and improved startup time. In embedded systems, saved memory in devices like sensors and IoT systems. And in web backends, like reduces latency in services applications, like in serviceless applications or game development. A game engine kept physics routine for removed game objects. Eliminating dead physics code increases average FPS from range 55 to 72 on mid-range hardware. So improved FPS by removing unused physical code. So even a small amount of dead code can have a big impact in real systems. Here is a simple example. Before there's an unused variable, if false block, an unused function. After all unnecessary parts are removed, this is a simple code. Lines of code reduced from 12 lines to 4 without changing the output. Dead code elimination is already implemented in modern tools, mentioning like in GNC Clang performs dead code eliminations automatically at optimization levels 2 and 3 via CFG analysis. This optimizes the flags and LLVM pass removes instructions whose results are never minor. It is kind of advanced these dead code elimination process. Java JVM run it's an runtime optimization identify the eliminating methods never invoke. And there's a webpack with a tree shaking and then ProGuard for Android apps and Rust link time optimization combined with DCE eliminates dead code across create boundaries at link time. So developers don't always have to do it manually. Compilers itself handle it automatically. Here are some key takeaways. Dead code is any code that is never executed or whose results are never used. Is unused or unreachable code. For five ways. Type include unreachable code, unused variables, unused functions, and redundant computations. Compilers use control flow graphs and liveness analysis to identify dead code. Like it affects the performance and efficiency. And benefits faster programs, smaller barriers, better security, and easier maintenance. Real tools, GCC, LLVM, JVM, like we have talked before in before slide, all this. Removing it makes performs faster, smaller, and safer. So these compilers detect it using CFG and analysis. So always remember that good code is not just about writing more, but writing only what is necessary. Thank you for listening. I hope this gave you a clear understanding of dead code elimination. Yeah, thank you.